So yeah, what the topic discussion just have been about is about figuring out how do we get this structured data, what do we have, and then afterwards, of course, you can figure out what models is there, and then train them and see some results. So together with Northbridge, we came up with 2 models. We're going to use, we have used quite a lot on the last 6 months with a handful of our clients. So we call it the data first approach or the problem first approach. So the data first approach is where we sit down and figure out what kind of data do you actually have, and then kind of brainstorm what can machine learning be used for with this kind of data. The other one is what Christian also mentioned earlier is trying to identify a pain in the business and see if machine learning can be used to solve that, and then checking the data afterwards or figuring out what data do you need to start gathering to use this. We see this as a sprint, like for a week, and then in most of our cases, if we just go with something like 100 hours, 2 sprints, we can actually show quite good results. So it was mentioned on the T-shirt project, that was actually just 1 sprint. That's now is now going into a like a prototype for the client. And also for the other project with the search engine, that was 2 sprints. So you don't need to invest thousands of hours into getting started in this. I think that's our approach. But keep it simple and look at the data, or figure out what data you need to store is, of course, the key points of getting started with machine learning. I don't know if there's any questions to this model.
Just so how many people from the client side would you suggest take part in this?
Yeah.
How many people should you arrange internally in the company?
So I think the best solution is to have someone who knows what data is out there, like someone from the IT department or data warehouse, or someone can actually dig down and show us some data on the workshop, on the first meetup, and then of course having someone from the business side and trying to understand where is it you want to go in the future, and can we combine these 2 things. That's the most important things, the most important ones to have in the first workshop.
And also for someone that knows the business, like someone who can identify the pain and identify a valid solution. Because when you come in as a data scientist and you look at a problem, you don't know necessarily the business side, so you need to have a close collaboration with someone who knows the business well, so you can iterate on a good solution. So, data and business.
And this is 1 week, this is 1 sprint.
Yeah, we'll go through that. And then, so either you can dig deeper in, so after the first sprint, figuring out how can we improve it, or you can try another issue. So with the search engine optimization we tried quite a lot of things. So one thing was looking at the keywords. We also tried to improve their current system using other technology. So we tried like a handful of different approaches over like a couple sprints, and came back when some of them was like dead ends, and some of them was like definitely continue this direction. Okay, cool. I think that's the last slide.
Super. Okay, yeah, please come up on stage, Thomas, as well. And yeah, let's have a Q&A session. What are your thoughts on the challenges of implementing and using machine learning?
I have a question. There were 10 goals for you, and one said predictive maintenance. How much have you done of that? Automated work orders. We have a lot of IoT systems telling that something might be close to breaking down. Does it send automatically a work order, and you'll be able to pick up the things next day just go do it?
So we haven't done any predictive maintenance specifically, but we have worked with live systems and live real-time data, real-time predictions, and in that setup, the most important thing is have a good cleaning process of the data. So when you work in machine learning on a classical way, you have the data, you sit at your desk, you clean the data, and then you have nice pristine data, and then you train the model. When you have real-time data, it's very important that your cleaning process, your pre-processing of the data, is as much part of the model as the actual machine learning model. So I think that's the most important thing, working with real-time data.
I have a comment.
Yeah.
So we have a very early stage proof of concept, you could say, with linear. So linear actuators, motors going up and down for their medical beds. So in a hospital, the elevation beds, they need this preemptive maintenance. So it's still on a, you could say, conceptual level, not implemented yet. But the goal here is that they have these guys fixing the beds, and sometimes there's nothing to do, and sometimes you get flooded with 10 beds at a time. So trying to ease out the maintenance part. So it's still conceptual, yes, but there are definitely interesting parts. And I guess from a data perspective, it's easier since it's not a lot of different variables for that specific motor. It's something about amounts of usage and how much weight, was the guy in the bed bigger or smaller, that type of thing. So it could be.
But I see more that as preemptive, whereas say predictive.
Oh, sorry.
For example, if we have IoT systems saying that a fan is all of a sudden getting out of motion, so instead of doing preemptive, where every half year you'll change it, it can run a year. We don't know. But we change because it needs to be changed according to the schedule, and we might be losing a lot of money doing that. And if we could do predictive, they could tell us, okay, it can actually run a year. So we save 50,000 per fan.
Yeah.
A year. That's a lot in an airport.
For sure.
You're burning 40 million, 40 billion.
Yeah, not enough.
Are you already collecting this data, or?
We have about 50,000 measuring points, but we don't use it correctly.
So, but do you have a lot of history collected?
None.
None? Okay, because that's the...
Apparently goes right out the window. I
yeah,
just
okay.
want to look into it.
Okay, because that will be the main thing to collect.
I know.
Yeah.
Yeah, anyone else?
I have a question for Mr. Thomas.
Yes.
So back to the governance part, I'm thinking that a lot of the companies here might not have this whole innovation board structure and decision making. I was interested, since it was 6 months old, so how often is the board involved in reviewing this portfolio? Is it an ongoing thing, or is it a year per year budget thing, or like how does that work out? And going back to before that, what did you do then? Because if you don't have this structure, then what shouldn't you get started either on the structure, or could you get started on just small projects?
We have this board with the CEO, CFO, CIO, CEO, all the C's, and we meet up every 6 weeks. You could say there was another slide, but slightly below that. The CIO and the CCO, so the IT, global IT department and the global commercial department, is working more closely with this also. So we actually work not on a daily, but maybe a weekly basis with the director of IT and director of commercial. So we have a lot of interaction. And yes, if you don't have that structure, then things are more difficult. What we saw was that innovation happens everywhere, but it can easily become competition as well. You need to have both business and IT working together. Like we said, data and IT, then you have machine learning. So I think that it's definitely better.
So for the people here that does not have this governance, your first step would be to implement some sort of governance instead of trial and error, or just getting started on something.
Yeah, I think if you're looking at DSB as a company, everyone with a little, everyone who has a small department or has a little power in the organization can go and do a machine learning project. They have the budget, they have the people working there, they have the problem, they can do it. But of course it's easier when you work with the IT department because they own the governance for data and stuff like that. So I think everyone can do it, but it's easier when you have the right people involved.
And another thing is that if you want to move your system into production, it's quite important that you have the IT department on your side. Because if you do it on a laptop somewhere, and then you need to then go and talk to the IT department, then it's almost a new project starting over. So that's important to have the IT department with you.
I think actually a lot of the machine learning projects run on laptops.
Yeah.
Under the radar.
Yeah, probably.
Yes, question?
It was regarding this case you had about the pre-alert system. Are you actually able to see what is actually statistical uncertainty on an alert? Is there a chance that the delay will happen with 50% certainty or with 20% certainty or something like that?
Yeah, we measured that. So we have, of course, it depends on how much slack we build into the model. So say, do we want to predict exactly, is it late or not late, and when we do it. So of course we're better at predicting if it's going to be late just before it's about to be delivered than we are 2 days before. So we have run statistics on that based on historic data. We did that as one of the first proof of concepts we did before we had live data streaming into the model. We took the data dump and separated 20% of the data, tried to run that through and see how good was the model actually. Was that the answer to your question?
But is it something which you're sending out these emails with this information? Is it something which is added to the emails, or is it just saying, well, there's a risk that this will be delayed? It's not saying anything about what's the chance that it will be delayed.
Yeah, what we actually do is that we predict when is it going to be delivered. So we have a time that it should be delivered this time, and we predict it to be actually delivered at this time. So what you can see is the margin, or the difference between those two numbers. So we don't give, there's a 90% certainty that this will be delayed, but we estimate it to be 12 hours delayed. That's a lot, so it's probably true.
Yeah. Yeah. Question.
I think that we can all agree that within just the last couple of years, there's been like a revolution in cloud tools, making machine learning much easier and much more accessible to everyone. So back in the days, there was this saying that nobody ever got fired for choosing IBM. So what's the equivalent cloud platform today when doing machine learning?
Yes.
Just your say, of course.
So yeah.
So for us, it's like Amazon and Google have been really big, but also like our Microsoft department, they will probably say Asia is just as good. I think they are really close, all of them, also in price, these three. And so Microsoft was a lot behind for many years on the cloud platform, but the last couple of years they've been almost regaining that again. So they're really close at this point. And like when you look straight at hardware, it's almost the same, but of course they have different services. And Amazon is better at something, and Google is better at something. So it depends on the problem a bit.
Yeah, and also a point with these cloud services is that they work well on very specific tasks that are easily like generalizable from, like for example, optical character recognition, OCRs, stuff like that, or translation or speech to text, or something that is similar for everybody using the service. If you want to do more specific tasks, for example, tracking IoT stuff or even your project, it will be quite difficult, I would say, to fit it into their frameworks. So using these cloud services, your project or your problem needs to be very like common, a very common problem. Like, yeah.
I think that at least Asia at least differ from that perspective, because they have this whole programmable layer in front of all their modeling that we use for real-time cleansing and gathering of IoT-like data. Yeah. So that's like a whole funnel that actually results in attributes that are then put into the model. Okay. That's why we chose that one. But I mean, we chose that and we'll probably never look back. So I'm just like would like to revisit that decision every once in a while because it's moving so fast.
Yeah, for sure.
So, like, I think that you can look at it 3 ways. So you can buy hardware, and then there's these really specific services, APIs, where you can send a picture and see text, as Christian said. And the last thing is these configurable SaaS products, where Azure is one of them, but there's also big ML, and Amazon have one as well. So what they do is, like, you can upload a lot of data, you can train different models in there, and you kind of see how they run, and then you have an API to do predictions. But so it makes it like drag and drop interfaces instead of sitting with TensorFlow or Python. And now I want to try out this model. I want to try it with these configurations. Yeah, exactly. And like, we made a research 1 year ago, and we decided to, for that project we went with big ML, which is probably is the one we've been in the field longest time, and it was the one where it had the most intuitive interface and really good APIs. We tried Amazon in the beginning, and as most Amazon is very, like you say, like unintuitive. It takes a lot of learning curve to get it and understand. But yeah, our Microsoft department, they use Azure a lot, and it's also part of Sitecore as well.
So I guess the equivalent would be any of the big ones.
Yeah.
They're really close. I think they're within 10-15% of each other at any point.
I've heard that Azure is one of the prime ones.
Yeah.
IBM Watson is one of the lower ones.
IBM Watson. Yeah, I have heard bad things about that. It's like lagging behind. There were some hackers at it was like a Microsoft hackathon actually. But yeah, so we had access to the IBM stuff.
Do you have a question here?
Yes. Are you finished with your project?
We can. No, we haven't scaled it. If you look at the model we have, we haven't scaled it to full extent.
But are you just going to scale it or continue improving it?
We're going to continue improving. So the answer is yes, this part is working and finished. But of course, we're not satisfied with that. That is for one customer. So that's not really moving anything for the company. So we need to scale that specific part to the rest of this part of the operation, and then we want to also build on that. Because now we have this one working with the GPS on the trailers, but you also have AIS, the similar for ships, vessels. So you could do basically the same for air and sea. And of course, like the dream scenario is that we can do that for everything we ship.
Okay, but I'm thinking if you move a bit forward, find out why is it late. Can you find out if it's because of weather? If Google Maps will tell you there's something wrong on this road every time you're late, and after you do that, you can say, okay, we can now make sure we're never late, or at least prevent being late a lot of times.
It's interesting because when we did this project, we worked very closely with the business, and what we figured out in the beginning was that all of these shipments, they go on a ferry at some point. So they are in the trailer, but the trailer goes on the ferry. On the ferry, we lose the signal, so we don't have the signal. That's also a challenge. But what we figured out is that the challenge, the point where that really defines if we are late on time is if the driver reaches the ferry on time. If it doesn't reach the ferry on time, we'll have to wait a long time to get on the next ferry. So we figured out that this was the very most important point. And then, sure, weather and stuff like that also is important, but compared to reaching the ferry, it was nothing.
That's also good. Tell, and you can prevent it then by having to go a bit earlier, or at least predict when it's going to leave the ferry.
Yeah, exactly.
And I think we have actually have scanlines in the room here, so that's kind of interesting. On that. I have one question, because we have a lot of bright minds and interesting companies today. I've talked to a lot about proof of concepts in terms of machine learning. We've done some proof of concepts with our clients, but do you want to share any thoughts and learnings or projects that you've worked with? Anyone? Yeah.
I can show you the Kepler stuff I'm talking about, like how easy it is to visualize probability days. If you want to, it takes like 5 minutes.
I don't think we have 5 minutes, but
1 minute, but
yeah,
whatever.
If you just want to show it, yeah.
Yeah.
Maybe we can do
I
that.
just uploaded like some. It's called Scooter in English, but Løbehjul. Data. I don't know if I have something like that. No, my Mac is total.
No,
But
you
is
should
there
have the-
HMI?
Yeah.
Yeah, cool. Yeah. And you can just talk if you want to talk about something else.
You just talk.
Okay. But
Anyone
this is
else?
just like, yeah, okay.
Anyone else want to share their thoughts, learnings? No? Still very early stage for a lot of people. But,
This is not machine learning. It's just nice ways to get the top management to have fun. And that's not it. I think it's and my computer is dying. So yeah, it's there, but my computer needs to wake up.
So what are we looking at here?
We're looking at mobility data where you can see the path, and there's like a brush on top of it, and it's not me who developed this. It's just open source, and it's like super simple. So if you have some put JSON like a field with like SVG area, I don't know how to explain it. But if you have like areas you want to like highlight something in, then you can just upload it here, drag and drop, and then you can put in some data. Yeah.
Okay.
So, yeah. My computer is really slow.
So does the data need to be in a specific format?
No. As long as you just have the latitude and longitude, and then you have like something, then you can just like, whoop, and then it's. So a lot of like my experience, I work at Wonderful Copenhagen, and my experience is that there's a lot of cheeky suppliers who want to make their own customized D3 dashboard, and it's like the price is about perhaps 100 or 200,000, and there's no limit to the skies. But this is like so simple, so it's nice for us that we don't need to go out and get like a customized front-end dashboard, and we can just do this ourselves.
But this is not real time, right?
But you can also attach it to an API. It's like open source in GitHub. I can just show you, like, so if my computer is responding, yeah, whoop, and then I just say this, get started, whoop, and then I take a file somewhere. I don't know what this is, but I will try to find the right data file. It's here. Whoop. Now it's reading the format, and voila. You can use, you can do whatever you want with it. And it's really, I think my mom could do this. And that explains a lot. She's really sweet, but yeah. So that's like the point with it. So you can see here you have like the roots and all the stuff, and you can fill this on it, and it's just easy. And that was it.
Super. Thanks for that.
Thank you.
Yeah. Okay. Yeah, I think that that wraps us up for today. So we hope you enjoyed all the good knowledge and insights about machine learning. We hope that you'll go back and have a more practical, clear understanding about this, and the importance of keeping it simple and defining a specific project with the specific data to get started, and then prove that to the business. So we hope you had a great morning, and thanks for showing up. Have a great afternoon. Thank you.